Hello and welcome. This is going to be our Q&A session for April 10th. So you guys submitted these questions to me via the survey on my calendar. That survey, it's the same survey, is going to stay up all of the rest of the semester, and we'll keep doing these Q&As once a week. So if you run into problems that you can't, help yourself out of, feel free to take a screenshot or just type in the question in that survey, and I'll keep doing these videos and answer you guys' questions. One thing I'm going to do, especially if these get much longer, is I'm breaking them up into class. So I'm just recording one video for all three classes that I teach, but I'll put little timestamps where you can jump to your class. All right, so without any further ado, we'll cover some questions from Algebra 2 Trig. Somebody who, so I gave you the option of how you wanted to be identified in these videos. Most people went with anonymous. So our first anonymous asked, is there a specific way to solve word problems? I'm assuming since we just did word problems with trig, you're talking about that trig word problem sheet. Here's just a couple steps to help you out. One is to either pick sine or cosine. All right, and how you're going to do that is based on the word problem. If we're starting at a maximum or a minimum, use cosine because it's very easy to get that to work out. So cosine starts at a maximum, but it can be very easily flipped to start at a minimum if you just change the a value to be negative. So cosine is good if we've got a word problem that's starting at a maximum. Sine, its y-intercept is a midpoint, so it starts at a midpoint. And then it specifically goes up from there, but if you need it to go down from its midpoint, you just make it negative. So that's what I would say is pick either sine or cosine. And then the next two things I do are midline shift. And midline is pretty easy to get because you just average the max and min to find the midline. And then I like to do the amplitude shift. And once you found the midline, you just do max minus mid, and that tells you the amplitude. Or you can take the distance from maximum to minimum and then cut it in half. Both work. All right, so this should have the midline in the right spot, amplitude in the right spot, with the right, or close to the right starting value. All right, next you want to figure out your period. So the period for sine and cosine is 2 pi, so you just do 2 pi over b equals the period. Plug in whatever period you want over here and then solve for b. So I guess we can rearrange those. Let's multiply b to both sides, divide period to both sides, so b equals 2 pi over the period. So say I don't want it to cycle every 2 pi, I want it to cycle every 100 units. I just put a 100 down here, so now it'd be 2 pi over 100 or just pi over 50 for my b value. And then lastly, we're going to fine tune phase shift. And I always think about either moving a midpoint where it needs to go or moving a maximum where it needs to go, depending on if you started with sine or cosine. If you started with cosine, move the maximum to wherever it needs to be. And phase shift is h over b. So if you know the phase shift and you know the b, you can just multiply them to get h. So phase shift times b equals h. Okay, and now fortunately, another person submitted one of the questions from that worksheet to the survey. So we'll just use this question to practice those techniques. So astronomers have noticed that the number of visible sunspots varies from a minimum of about 10 to a maximum of about 110. All right, further, this variation is sinusoidal, repeating over an 11-year period. If the last maximum occurred in 2003, maximum, write a cosine function n which predicts the phenomenon in terms of the time t, which represents the year. So I think it would make sense for t to be years since 2000. We could do years since 2003, but I feel like that would just be like a little bit cheeky, considering then we wouldn't have to do a phase shift at all, and years since 2003 is kind of just a random. Well, starting at 2000, that seems a little bit more natural. Okay, so we'll say t is years since 2000. Let's find that midline. Well, actually, first we got to pick, I'm going to pick cosine because of this word maximum here. So I pick cosine. All right, now it's time to find the midline. It's going to be halfway between the minimum and the maximum. So add these together, divide by 2, and we get 60. So that's going to be our k value. It's going to be our vertical shift. So right now the equation looks like this. Y equals cosine of x plus 60. And I'm going to do this in radians. All right, now let's find the amplitude. Well, what's the distance from 60 up to 110, or from 60 down to 10? It's 50. So the amplitude equals 50. So now we've got y equals 50 cosine of x plus 60. Now we got to figure out our b values. So b equals, what did we say? 2 pi over the period. So b equals 2 pi over the period. So 2 pi divided by, our unit is years, so we can just use the 11 here. And then we just got to find the h. So the phase shift, I want to go 3 to the right. So how did we write this formula? We said phase shift times b equals h. So I want to go 2 to the right times my b value of 2 pi over 11 gets me an h value of 4 pi over 11. Now remember, we're going to subtract that in because you always subtract in your h values. All right, and that gives us the equation y equals 50 cosine of 2 pi over 11 minus, or x minus 4 pi over 11 plus 60. All right, I'm going to pause the video real quick and plug this into my calculator and see what it looks like. Okay, when I was setting up to graph it, and there's a slight mistake. I said I wanted to shift 2 units to the right, but the maximum happens in 2003, so I want to shift 3 units to the right. That changes this number here to a 6. I was able to catch that when I plugged it into the calculator. And here is that graph. You can see it cycles up to hit a maximum, and this would be 2003, and then it's going to cycle every 11 years. So if it hit a maximum in 2003, then we'd expect another maximum in 2014. Let's see if that's what the table shows. So let's see, we have our maximum of 110 in 2003, and then in 2014 we hit a maximum again of 110. And yeah, we can now use this model to go make predictions and look forward. If this was actually true, then this year we'd expect to be pretty close to a minimum number of sunspots at 12. Okay. Another person submitted this question. Looks like a question from rational functions. We need to simplify this. These are called complex fractions when they look like this. Oops. Double check this is still recording. Yep. Okay, these are called complex fractions when they're fractions made out of fractions. And what we want to do is we want to simplify them by just taking it down, combining two fractions at a time until we're left with one fraction. So I'm going to ignore the bottom part and just simplify off the top here. 5 over a plus 5 over 4. So 5 over a plus 5 over 4. These denominators do not match at all, so we got to multiply them by each other. So I'm going to multiply this side by 4 over 4 and this side by a over a. And I get 20 over 4a plus 5a over 4a. And now that the denominators match, I can add the tops, and this becomes 20 plus 5a over 4a. Look to simplify, no common factors here. So now this is going to come in and replace this. Now my fraction looks like 20 plus 5a over 4a all over. And it's important that this is the bigger fraction line here. You have to keep track of order of operations. It does matter. And from here we want to copy dot flop this, but I just show it like this. The top of this goes to the bottom of this, and the bottom of this one goes to the top up here. It kind of makes like a sideways rainbow. And I'm going to be sure to distribute it into this term here. So now I've got on top 80 plus 20a after I distribute that 4 to this 20 plus 5a. And on the bottom that becomes a 4a cubed. Now I do see I've got at least a 2 I can divide away from the top and the bottom. So I have the top and bottom by 2. And I get 40 plus what is that? That's a 20 there. That's a bad 20. Plus 10a all over 2a cubed. And there's, it looks like I can take out another 2. Divide everything by 2 again, and I get 20 plus 5a all over a cubed. Okay, good question with this complex fraction here. This is simplified because it's just one fraction and there's no negative or radical in the denominator. All right, had another question about how to graph this one here. So here's how I graph tangent. First, we got to know what the parent function of a tangent wave looks like. So tangent, it starts at 0. The tangent of 0 is 0. We can double check that in our calculators by just doing tangent of 0. Doesn't matter if you're in degree or radian, 0 is 0. We'll get 0. All right, then tangent does this thing where every pi over 4, we hit a key point. So at pi over 4, we're up at 1. And then at pi over 2, we're undefined. And then we hit -1, 0, 1, undefined. And so these are good key points to keep track of while transforming tangent. And I'm just going to keep track of just this middle set here. So here's our tangent wave. Goes in between these two vertical asymptotes. And at negative pi over 4, we hit -1. At 0, we're at 0. And at pi over 4, we're at +1. So that's -1, and that's +1. Okay, so we've got to perform all of these transformations to this graph here. And the easiest, we'll just do the easiest one first, which is this 1/2. Everything gets half as tall. So now our key points. I'm going to zoom in. The 0 hasn't moved, but at pi over 4, we've gone from being up at 1 to now just being at 1/2. And the same with this point over here at negative pi over 4. We're at 1/2. Okay. Now we can do the vertical shift. Let's see, would that be... Oh yeah, it's fine. We'll do vertical shift, so everything's down 2. At this point, I can fit that one here. So this was at 1/2, so now it's at -1.5, -2, -2.5. Just keeping track of those 3 points. Okay, now let's figure out the period and phase shift. We gotta do a little calculation for this. So the period for sine and cosine was 2 pi, but for tangent, it just is every pi. It doesn't go up and then down, it's just always going up, so it's half the period. So we're going to do pi over 2 is our new period. So instead of cycling from every pi, do I have these key points right? Let's see, because it goes, yeah, because then the next key point out is pi over 2 where we hit the vertical asymptote. So now everything's got to get compressed to pi over 8 and negative pi over 8. Okay, let's see if I can draw this. So these points here, this one's still at negative 2, but these ones have gotten squished in to pi over 8 and negative pi over 8. And they're still at, negative 1.5 to negative 2.5. All right, and then the last shift is the phase shift, which is always h over b. Tells you how far we have shifted. My h value here is pi over 3. My b value is 2. So 2 pi over 3 over 2 becomes pi over 6. And that's going to be to the right, pi over 6. So I got to find my new key points after I've moved everything right, pi over 6. So what's pi over 8 plus pi over 6? The nearest common denominator, let's see, would be 24. We can make this 3 pi over 24 plus 4 pi over 24 equals 7 pi over 24. And then if I made this one negative, I would just end up at pi over 24. And pi over 6 would be my other key point. Okay, let's see if we can do a decent job graphing just one cycle of this tangent wave. So this point that was here is moved over to pi over 24, and it's still down at negative 2.5. And then at this point that was at 0, it's been moved pi over 6 over, so at pi over 6, we're at negative 2. And then at 7 pi over 24, we're at negative 1.25, or just negative 1.5. All right, and then it's gonna swoop through like that. So if I had to graph it without any points, I would know you got a little bit narrower, and one cycle is moved over here-ish, and the kind of curvy part is lower down. So that's my best estimate of what this would look like if you had to graph it by hand. But if you've got your calculator, you're gonna save yourself a lot of time. Okay, let's just zoom out on this one real quick. Yeah. Well, we got to see some good math there. I don't know if that. I would never have you graph one of these by hand. It's more about using your calculator and then picking the correct graph, making sure you're on the right mode, knowing what each of the transformations does. All right. Michael asked, can we have Sprite Day? So I took this picture. You can pull this up every time you're having honorary Sprite Day, every Wednesday. I'll be drinking a Sprite with you guys in spirit. All right, on to Algebra 1A. Here are the questions you guys submitted. Anonymous said, do you know when we'll get the scores from the quiz from last week? Those should be in Infinite Campus. I'm going to close out that quest very soon. If you're confused about your score at all, send me an email. But yeah, so with these online quizzes, I'm going to wait until the deadline, and then I'm going to grade them all and just send out the scores. And at that point, once I send out the scores, like to your email, then the quiz is going to be totally done. You won't be able to make it up again at that point. And I'm not going to be reopening the quizzes or anything. It's just I'm giving you guys plenty of time during the window for that actual quiz. Get it done then, or else you're not going to be able to get points. Not that that hurts you, but it can't help you at that point. Another anonymous. I really just want to get my grade up. That's my question. So to you and everybody who has this question, I would say those Khan Academy assignments to get points back on the test are still open. Those are due at the end of the semester, so do those and send me an email when you're done. I'll give you those points. Do all of the stuff on the calendar that we're currently doing, because that stuff can only help you if I put it in the grade book. Send me pictures of your homework, and then go find some of the old stuff and do it and send me pictures and replace those missings. Look for like projects and take-home quizzes, especially. Those are going to improve your score the most. An individual who wanted to be identified as Chocolate Thunder said, "Hi, Mr. O," and then signed it Lewis. So, hi, Lewis. And I think I'm missing one. There's another anonymous that says, what's your favorite food, Mr. Olson? For favorite food, I know it's a little cliche, but I'm going to go with pizza. And that's because I like to make it myself, especially. I like to make the crust and do lots of different toppings. Traveled around Italy a few times now. And when pizza is really good, I think that nothing can beat it. Also like sushi a lot. So whoever asked, what's your favorite food, Mr. Olson? Those are my answers. Pizza and sushi. I know they're boring, but they just can't be beat. All right. Well, that's that for this Q&A. Have a good rest of your day.